Questions 11 through 20 on the 2004 Grade 8 AMC 8. The numbers -2, 4, 6, 9, and 12 are rearranged according to these rules. The largest isn't first, but it is in one of the first three places. The smallest isn't last, but it is in one of the last three places. The median isn't first or last. What is the average of the first and last numbers? So we have to play a little bit of a game here. We've got 5 slots, and let's take this one step at a time. So rule number 1, the largest isn't first. So the largest is 12, right? So 12 cannot go there. But it is in one of the first 3 places. Okay, so that basically means it's either here or here. The smallest isn't last, but it is in one of the last 3 places. So the smallest is -2. It can't be the last, but it is in one of the last 3 places. All right, so that basically means that the -2 is there. The median isn't first or last. The median is 6. That's the middle value. And it cannot be here and it cannot be there. So it's obviously somewhere in here. 6. So regardless of order, we know that these 3 middle numbers are 12, 6, and -2. Which order, it doesn't really matter. So this guy here, first one and the last one, are the other 2 in the list. And the other 2 in the list are 4 and 9. 4 is either here and 9 is here, or the other way around. But the order doesn't matter because we just want to find the average of the first and last. The average is 4 plus 9 divided by 2, and that'd be 13 over 2, which is 6.5. So number 11, the answer is C. Nikki usually leaves her cell phone on. If her cell phone is on but she is not actually using it, the battery will last for 24 hours. If she is using it constantly, the battery will last for only 3 hours. Since the last recharge, her phone has been on 9 hours, and during that time she has used it for 60 minutes. If she doesn't talk anymore but leaves the phone on, how many more hours will the battery last? So if her phone is on, she gets 24 hours of battery life. If it is in use, she gets only 3 hours. So when it's in use, it drains the same amount of time, but it does it a lot faster, as you can see. So 1 hour of use drains 8 hours of on time, right? If it's in use for 3 hours, it would drain 24 hours of on time. That's the comparison. So now let's look at our question. Her phone has been on for 9 hours, right? And during those 9 hours, it was being used for 60 minutes. So it's only being used for 1 hour. So that means of those 9 hours, it was on for 8 hours, but not being used. Now, I just wrote that 1 hour of use drains 8 hours of on time. So she has used it for 1 hour, but that really drained 8 hours of on time. So the amount of on time that has been drained is 8 hours right there and an additional 8 hours. So we start, of course, with 24 hours of on time when the phone is charged. We drain 8 from here, and then we drain another 8 from right here. So what's left? 24 minus 8 minus 8, 24 minus 16, which is 8. 8 hours of on time is remaining. And therefore, number 12, the answer is B. Amy, Bill, and Celine are friends with different ages. Exactly one of the following statements is true. Bill is the oldest, Amy is not the oldest, Celine is not the youngest. Rank the friends from oldest to youngest. Only one of these statements is true. Okay, let's work through these. So Bill is the oldest, and Amy is not the oldest. Only one of these statements is true. So let's just look at the first two. Bill is the oldest. Let's say that's true. Amy is not the oldest. That has to be false according to the fact that only one of those can be true, right? Both of them cannot be true. Our rules are listed in a way that only one of them is actually true. So let's just go with this. If Bill is the oldest is a true statement, then Bill is the oldest. All right. Now, if Amy is not the oldest is a false statement, that means Amy is the oldest. Well, we've got inconsistency. Bill is the oldest, Amy is the oldest. Well, that doesn't make any sense, right? So this scenario cannot be the correct scenario. So true and false, no good. But what about true and true? Well, that can't also work because only one of them has to be true. So the only way is if they're both false. That's the only way this is going to work. If they're both false, that means by process of elimination, this has to be true. Celine is not the youngest, must be true. If that is true, then let's look at the answer choices. Celine is not the youngest, remember that. In A, Celine is the youngest, so that can't be the right answer. In B, Celine, again, is the youngest, so that can't be right. And let's see here, in C, D, and E, Celine is not listed as the youngest. So now we have to figure out which one is correct, C, D, or E for number 13. Well, let's look at the other one. Bill is the oldest, that's false. So Bill is not the oldest. Is Bill listed as the oldest in C, D, or E? Well, no, so that didn't help us. How about statement number 2? Amy is not the oldest is false. So that means Amy is the oldest. C, D, and E. Amy is the oldest right there. Celine is not the youngest. That also matches. And Bill is the oldest is false. And that also matches. So this question is really a, kind of a trial and error. Let's think about this for a second. That kind of thing. So 13, the answer is E. What is the area enclosed by the geoboard quadrilateral below? So I'm going to partition this into segments like that. And then each of these areas, I'm going to give it a name. I'm going to call this one A. I'll call this one B. This little guy in here I'll call C, and D, and E. And then this Nike-like check mark is basically what we are interested in. So the way to do this, there's several ways in fact, but I'll just say that our Nike check mark, it's basically the total area minus A, minus B, minus C, minus D, minus E, right? I hope you agree with that. All right, no problem, let's figure this out. The total is, it's a 10 by 10 grid. So it's 10 by 10 is the total area. And then A basically is a rectangle with the dimensions 5 and 3. So it'll be 5 times 3. B is a triangle with the dimensions 6 and 7. So 1/2 base times height would be 1/2 6 times 7. C is another triangle with small dimensions 1 and 3. D is also a triangle with dimensions 1, 2, 3, 4, and 5. And finally, E is our final triangle with dimensions 6 and 10. And there you go. So this will be 100 minus 15 minus 21 minus 3 over 2 minus 10 minus 30. And if you do the math, you'll get 22.5. So number 14, 22.5 would be C. I just want to really briefly mention the Nike logo, which is one of the most famous logos in the world, was designed by a woman named Carolyn Davidson. Way back when Nike first began as a company in 1972. And when she was hired to design a logo, she made that swoosh, that famous swoosh logo, right? Which I've drawn in a terrible way here. But what's interesting is how much she was paid back in 1972 to design that logo. You ready for this? She was paid $35. That's it. Now that logo is world famous. It's basically more recognizable than probably anything. But the CEO of Nike, many years later, invited her to a special party. And in recognition of her amazing logo, he gave her a diamond ring with the Nike swoosh on it and a check for $1 million. But I later found out that it actually wasn't a check for $1 million, it was $1 million in Nike stock. So I think that was a really nice token of appreciation that Phil Knight gave to Carolyn Davidson many years after she designed that iconic logo. "13 black and 6 white hexagonal tiles were used to create the figure below. If a new figure is created by attaching a border of white tiles with the same size and shape as others, what will be the difference between the total number of white tiles and the total number of black tiles in the new figure?" So originally, in this diagram, how many black tiles do we have and how many white tiles do we have? Well, they tell you, black tiles there's 13 and white tiles there's 6. What they're saying is they want to add another row. So they basically want you to add another row. Sorry, these are not hexagons. But you understand, basically another row of hexagons all the way around. And when you do that, you're going to create a new figure. And they want you to count the number of black and white tiles this time. And then they want you to subtract them. So figure out the difference. Okay, when you do that, what color would these blue guys be that I'm drawing in? Well, they're going to be white tiles, right? Because it's alternating. Black, then white, then black, then white. So because this new row will be all white, the black number doesn't change. It will still be 13. Now, the white was originally 6, and then we're going to add a bunch. So if I have done this correctly, let's see how many have I drawn. All right, I've got 1, 2, 3, 4 there, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so 4, 4, and 4. And then in the middle, I've got 1, 2, 1, 2, and 1, 2. So I got 2, 2, and 2. So 4, 4, 4, 2, 2, 2, what is that, 18? All right, so when you do it, it's an additional 18 white. So you get a total of 24. So now they want you to find the difference in the new figure between the number of black and white tiles. So the difference is just a subtraction question. It's 24 minus 13. And 24 minus 13 is 11. And therefore, number 15, the answer is C. Two 600 ml pitchers contain orange juice. One pitcher is a third full and the other pitcher is 2/5 full. Water is added to fill each pitcher completely, then both pitchers are poured into one large container. What fraction of the mixture in the large container is orange juice? So we got two containers here, and originally they're both the same. And the first one has 1/3 of orange juice. So 1/3 of 600 mLs, which would be 200 mLs. And very similarly, the second one is also a 600 ml pitcher, and it has 2/5 of it filled with OJ. and that would basically mean 240 mLs. Okay? Now what they do is they fill up the remainder with water, like that. So the water will be, in this one, 400, right? Because 400 plus 200 has to add up to 600. And the water in the second one is going to be 360 in terms of its quantity, its volume. And then they take everything in both of these pitchers and they put it into a big one, like that. So all of this gets dumped in here. And if you do that, you're going to have how much OJ? Well, you'll have 200 plus 240, which is 440 mLs of OJ. And how much water? Well, water will be 400 plus 360, which is 760. And now they want you to figure out what fraction of this mixture in the large container is orange juice. So OJ in this big one is basically 440 divided by the total. All right, be careful there. Don't put 760. Put the total. The total, of course, is 440 plus 760. So this is 440 over 1200. And now, I guess they wanted the lowest term, so 44 over 120, 22 over 60, 11 over 30. There you go. So 16, the answer is C. 3 identical friends have a total of 6 identical pencils. And each one has at least one pencil. In how many ways can this happen? So we got 3 friends, A, B, C. And the amount of pencils that A has plus B plus C is 6. So, and each of them has to have at least one, right? So basically just sit here and figure this out. What scenarios can you have? Well, friend A can have 1, friend B can have 1, and C therefore would have to have 4 in order for these pencils to add up to 6. And in a very similar way, just kind of plug away. 1, 2, 3. Would that work? Yeah, I believe so. 1, 3, 2, and 1, 4, 1. All right, I think we exhausted A equals the 1. So now let's try A equal to 2. This would give me these scenarios 2, 2, 2, and 2, 3, 1. And now we get to A equals 3, 3, 1, 2, 3, 2, 1, and finally A equals 4. A would be 4, 1, 1. So that's it. These are the possibilities. And how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 ways that this can happen. So 17. The answer is D. 5 friends compete in a dart throwing contest. Each one has 2 darts to throw at the same circular target, and each individual score is the sum of the scores in the target regions that are hit. The scores for the target regions are the whole numbers 1 through 10. Each throw hits the target in a region with a different value. The scores are Alice 16, Ben 4, Cindy 7, Dave 11, Ellen 17. Who hits the region with 6 points? So we got 5 friends here, and we have to figure out who, when they threw the dart, landed on the 6. So that dartboard basically has the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each of these friends throws 2 darts. So in total, there's 10 darts that are being thrown. And the most important sentence in the question is right there. Each throw hits the target in a region with a different value. So these 10 numbers over here can only be used once. And that's what we have to figure out. But they give us a little bit of help. They tell us that the total score for each of these is 16, 4, 7, 11, and 17. All right, so let's see what we can get. I'm going to first start with this guy right here, 4. what numbers can I choose over here to get a score of 4? And I think that can only be done in one way. 1 and 3. When he throws the dart, what's his name? Ben. If the first dart lands on the 1 and the second dart lands on the region with 3, his score will be 1 plus 3, which is 4. I don't think there's any other way, right? All right, so we take care of Ben. Now let's see, who can we move to next? Let's move to 7. How can we choose two numbers from here to get a sum of 7? I believe there's only one way, 2 and 5. So 2 and 5. There you go, took care of Cindy. Now let's, who do you want to turn to next here? How about D, which is Dave. With the remaining numbers, how do you get a sum of 11? And I think the only way is 4 and 7. So 4 plus 7 is 11. Now let's turn our attention to Alice. With the remaining numbers, when we want to get a sum of 16, and I think the only way that's possible is with the 6 and a 10. And then obviously these last two have to go down here with Ellen, 8 and 9, and indeed 8 plus 9 is equal to 17. So who hits the region worth 6 points? It's Alice. So 18, the answer is A. A whole number larger than 2 leaves a remainder of 2 when divided by each of the numbers 3, 4, 5, and 6. The smallest such number lies between which two numbers? So if we have a multiple of 3 and you add 2 to it, that will give you this number, right? Because if you're taking the number and dividing, you're going to get a remainder of 2. All right? In a very similar way, the number again is a multiple of 4 plus 2. So a whole number, it leaves a remainder of 2 when divided by 4. And similarly, I'm going to actually call this B instead of A because it's not going to be identical. 5C plus 2 is also N, and 6D plus 2 is also N. And if you want to rearrange this, if that makes it a little bit more helpful for you, you can. It'll basically be like this. A is equal to N minus 2 divided by 3. And similarly, B is equal to N minus 2 divided by 4. C is equal to N minus 2 divided by 5. And finally, D is equal to N minus 2 divided by 6. So the key in this question is looking at those three numbers. We got 3, 4, 5, and 6. We have to find something known as the LCM. What is LCM? Least common multiple of these three numbers. And the way you do that is first you break it up into its prime factors. 3 is already prime. 4 is broken up into 2 times 2. 5 is already prime. And 6 is broken up into 2 times 3. And now you find the least common multiple. And if you do that, you'll find that the least common multiple is going to be 2 times 2 times 3 times 5 for these four numbers. And 2 times 2 times 3 times 5 is 60. So that's the least common multiple of 3, 4, 5, and 6. So basically what that means is that when you take 60, you can divide it by 3 or 4 or 5 or 6. 60 divided by 3 is 20. 60 divided by 4 is 15. 60 divided by 5 is 12. And 60 divided by 6 is 10. So that number 60 works. But remember, our number is going to leave a remainder of 2. So n is not 60, n is 62. 62 divided by 3 would leave a remainder of 2, and the same would be true for if it was divided by 4, 5, and 6. So our number is 62. And they want you to figure out, of these answer choices, which interval does 62 lie in? Well, number 19 obviously is B. 2/3 of the people in a room are seated in 3/4 of the chairs. The rest of the people are standing. If there are 6 empty chairs, how many people are in the room? So 2/3 of the people, I'll call them N to represent the number of people, are seated, and they occupy 3/4 of the chairs, C for chair. And that basically means that the other 1/3 of the people are not seated, or in terms of what they say in the question, are standing. Not seated, standing, same thing, right? And that means that if 3/4 of the chair are being occupied, that means the other 1/4 of the chairs are empty. And the good news is they tell us that there are 6 of those. 6 accounts for 1/3 of the chairs. All right, perfect. So now 1/4 of C is equal to 6, so we can solve for C. C is 24. If C is 24, then 3/4 of C would be 3/4 of 24, which is 18. All right? If 18 people are sitting in 18 seats, that means this is equal to 18, right? So 2/3n is equal to 18. Solve for that, and you'll get 54 over 2 is n, and therefore n is 27. And just for completeness, 1/3 were standing. That means 9 people were standing. So what do they want? How many people are in the room? Well, that's n, and that was 27. So number 20, the answer is D.